Okay, so last time you finished with continuity, right? So in the next part, we will study about the derivative. Okay, so first let us understand what is the meaning of the derivative. Okay, the definition of it. Okay, so when you are learning in high school, right, you already familiar with finding the slope of the straight line already, right? So as you can see here, the slope of the line L is this line, okay, will equal to you need to know 2 points, right? So first is here, this point. So this one is f of x0, right? And here is f of x0 plus delta x, right? When you know these two lines, you can find the slope of the line by using this formula. Okay, so it means that change in variable of x, change in the variable of f, and over the change value of x. Okay, so derivatives have the same concept. Okay, we just want to find what is the slope of this particular point P. Okay, at this point, what is the slope of this point? So how are we going to do it, right? So from the above figure, right? We want to find the slope at this point. So how are we going to do it? We move this point, right, Q, to closer and closer to the point P. Okay, as you can see here, we move point Q closer to point P, and when we say closer, right, how much we want it, right? So we use the definition of the limit, right? From you already studied the limit, right? So how much closer? So it's this much, right? So you can see that here is the definition of the slope, right? This one is the slope of line L, right? And we move the difference between these 2 points to be closer and closer to 0. So we take the limit of delta x approaching 0. Okay, so this we will get the instantaneous rate, okay, at x equal to x0. Okay, when you not have the limit, you will get what we call the average rate of change. Okay, from x to x plus delta x. Okay, you will see this later on. Okay, the average rate, and when you take the limit, you will get instantaneous rate. Okay, and this is the definition of the derivative. You can see here we denote the symbols by using this one, f prime of x, to be the derivative, right? The definition is as above, the limit, okay, from delta x approaching 0 of f x plus delta x minus fx over delta x. Okay, okay, and when you want to know at x equal to a, then you can plug a into x, right? You will see in the example again. Okay, so I think you already learned that the derivative of the position, right, is the speed, right? So if you want to find the velocity at each time of when you have this thing, the position function, right? This is the position function. So if you want to know the velocity, you can just taking the derivative, or if you want just the average velocity, you can use this formula. So you don't need to take the limit. If you want it instantaneous, you take the derivative. Okay, you put in the limit. Okay, so you get that the velocity of the object can be described by this equation. Okay, so now we're going to see the example, right? In A, right, they ask you to find the derivative of x, right? So f prime x will equal to the limit of delta x approaching 0 of f x plus delta x minus fx over delta x, right? This one is your definition. So what is it mean, right? You can just plug in f of delta x, right? So this one will be x plus delta x square plus 4 minus x square plus 4, like this. Okay, just delta x. Okay, so f of x plus delta x become this one, and f of x will become this one. Okay, now is doing the calculation, right? So x plus delta x square will become x square plus 2x delta x plus delta x square, okay, plus 4, okay, and then minus x square minus 4, okay. If you have any question, you can open your microphone, or you can type in the chat box, okay, then I will answer over the text like this. And you can say that this one is x squared, this one is minus x squared, so it's cancel. Plus 4 and minus 4 also cancel. Okay. Okay, so I'm not sure that this one, do you understand that how we get to this one? Okay, so this is the red one, and the yellow one will become this one. Okay, for the yellow one, I just distribute minus into x squared and also to 4, so it become minus x squared minus 4. For the red one, right, I will just write here. So it's x plus delta x squared, right? You can use this formula a plus b whole square, right? This thing is equal to a squared plus 2ab plus b squared. Okay, A is horizontal, so this one easier. Yeah. Okay, so in this case, A is equal to x, right? So it's become x squared. This thing become x squared plus 2x delta x, okay, and then plus delta x squared, okay, and plus 4, right, from the equation. And I already tell you that this one is x squared, this one is minus x squared, so it's cancelled. Like you add 3 and minus 3, so it becomes 0. 4 and minus 4 becomes 0. Okay, so this one will have only 2x delta x plus delta x squared over delta x. Okay, from this you can see that limit of delta x here is delta x, here is also delta x, right? So I can combine it together, so it's become delta x, and it's 2x plus delta x, okay, over delta x, and this thing cancel with each other, okay. So this will left with 2x plus delta x, and when you take delta x approaching 0, you get just 2x. Okay, maybe wait a minute. Okay, so we finished with A part already. Okay, now we want for part B, right? They wanted the derivative at x equal to 5, right? Derivative of f at x equal to 5. I can just write it like this. Okay, and this equal to 2 multiplied by 5, which equal to 10. Okay, because we already found this one. This one is f prime of x, right? And we want at 5, then we replace x with 5, so we get already f prime of 5 is equal to 10. Okay, so I will go to the next question. Okay, is it clear? Last question, is it clear? For the next question, they ask you to find the slope of the tangent line, okay, of this function, okay, at this point. Okay, so when you think about the slope of the tangent line, right, it's your formula that you used to is m equal to y1 minus y0, right, over, right? You familiar this one, or which one? Okay, the slope is this one. But if they ask about the slope of the tangent line, okay, this thing is the derivative. Okay, so they ask you the derivative of x at x equal to 1. Okay, find the slope of the tangent line. Okay, so the equation is y equal to 1 over x squared, right? So what is the derivative of this equation? Okay, we want y prime, right, at x, or you can just write y prime equal to the limit of delta x approaching 0, okay, of maybe I just write like this. So it becomes f of x plus delta x minus fx over delta x. Okay, which equal to 1 over x plus delta x squared minus 1 over x squared delta x, like this. Okay, so the yellow part become this one, the red one become this one. Okay, now we're using the same formula, right? The a plus b whole square equal to a square plus 2ab plus b square. Okay, so this thing will become limit of x wait a minute. Okay, so first before I using this formula, right, I'm going to combine these two fractions into one first, right? How I going to do it, right? I will multiply x squared to numerator and denominator, okay, for the red part, and I will, maybe I'll just change color. Okay, x squared multiply x squared, and this one I will multiply by x plus delta x squared. Okay, and when I doing like this, you will get x squared, okay, and minus x plus delta x squared over x plus delta x squared x squared, like this. Okay, because Now the denominator is the same, the lower one is the same, so you can just combine it. You can subtract it easily. Okay, but not all. You also have delta x like this. Okay. Now you can using this formula to this one. Okay, and then you can work it out. Okay, this is one way, or you can use another formula, which is a square minus b square will equal to a plus b multiplied by a minus b. Okay, I will using the second one. Okay, so in this case, a is just x squared, right? A is x, so this thing will become limit of delta x x plus delta x and x minus x plus delta x, right? You can see here x is a and b is x plus delta x. Okay, over x plus delta x square and x square. Okay, now we just do the calculation. So limit of x, okay, x plus delta x become 2x plus delta x. Okay, and the second one, x minus x plus delta x, will have only minus of delta x left. Okay, over x plus delta x square x square or by delta x like this. Okay, from this you can rewrite it like this one, of 2x plus delta x and minus delta x over delta x x plus delta x square x square. Okay, and then you can cancel this with this one. Okay, so this one will become minus 1. Okay, is it do you have any question here? Okay, so when you are doing the derivative by using definition, it's gonna be a little bit confused like this. right? Later on, you're going to see the formula that you will can do the derivative easier, okay, later on. So this thing, I will just separate this to x over, so it's minus 2x, and x plus delta x square and x square, okay, and another one is delta x over x plus delta x square x square, okay. You can cancel this x with this, so you left with just x, okay. Now you can take the limit, okay. I will just rewrite it again first. Approaching 0 of 2 minus 2 x plus delta x square, and then x minus delta x plus delta x square and x square, okay. You take the limit delta x approaching 0, you will get minus 2 over x cubed, okay, and this thing will become 0, right, because this x square, the delta x will become 0, okay. So you get this. So this one is y prime, or the slope of the tangent line of the function. But the question is more specific because they ask you that they want the slope of the tangent line at x equal to 1, right? So you find f prime of 1, okay, this one is f prime of x. So f prime of 1 is equal to minus 2, okay, and this is the answer. Okay, is it clear? Okay, so next, okay, so in this example, right, they ask you that they already given you the distance equation here, okay. They want you to compute average velocity, okay, and instantaneous velocity. So this thing is the average rate and instantaneous rate, okay. So for the average rate, do you remember? Average rate is f of x plus delta x minus f of x over delta x, okay. For instantaneous velocity is the limit delta x approaching 0 of f x plus delta x minus fx over delta x, okay. So in this case, right, the function is depend on t, so you can write it as f of t delta t, like this, okay. Okay, so first let's find the average rate first. Average rate, average velocity, and Okay, so this thing is equal to f of, in this case, t is equal to 1, right? T equal to 1 and delta t is equal to 2, right? Because t plus delta t have to be equal to 3 here. Okay, the finish line. So this thing will become f of 3 minus f of 1 over 2. And what is the f of 3? It is the maybe here, right? When you plug in 3, it becomes 5 minus 2, 3 plus 3 squared. This thing equal to 8. Okay, and when you plug in 1 to this one, it will become 5 minus 2 plus 1 squared, and it become 4. Okay, so this thing will become 8 minus 4 over 2. Okay, which is equal to 2. Okay, that's it. For the B part, right? B part, you want instantaneous velocity. Okay, so you want to find f prime of t. Okay, so it's the limit delta t of f t plus delta t minus f of t over delta t. The function is 5 minus 2t plus delta t plus t plus delta t squared and minus 5 minus 2t plus t squared. Let me check. Okay, over delta t. Okay, this red one is this one, and the yellow one is this one. Okay, now you try to calculate this one, right? Become 5 minus 2t minus 2 delta t. Okay, I distribute this one. Okay, plus I using the same formula, a plus b all square equal to a square plus 2ab plus b square. Okay, so this thing will become t square plus 2t delta t plus delta t square. Okay, you can write it like this, and then minus 5 plus 2t minus t square. Okay, I distribute minus into each term. Okay, over delta t. Now you need to find the same component. So 5 and minus 5 cancel. Minus 2 and plus 2 cancel. T square and minus t square cancel. Okay, you will left with the limit of delta t to 0 of minus 2 delta t plus 2t delta t plus delta t squared over delta t. Okay, and this thing you can, there are delta t in common, so I can put delta t in front, and inside you left with minus 2 plus 2t plus delta t, okay, over delta t. It can be cancelled. The remaining is just minus 2 plus 2t plus delta t. Okay, and when you take the limit delta t equal to 0, you will get minus 2 plus 2t. Okay, so now you done with the B part, right? Because they want the instantaneous velocity of the object at t second. For the C part, they want it at t equal to 1, right? So C, they want f prime 1, which equal to minus 2 plus 2 multiplied by 1, which is 0. Okay. Okay, so the above is how you solve the derivative, right? By using the definition of the derivative. Next is the very important theorem, okay, which they say that if the function is having the derivative, okay, or you can say the function is differentiable, okay, if it has the derivative at x equal to a, it implies f is continuous at x equal to a. Okay, so the derivative is that the limit of delta x to 0 of f x plus delta x minus fx over delta x, right? This thing means this exists, okay? And the continuous, can you remember the continuous at x equal to a? So it's the limit, right, at x approaching a from the left of fx, right, equal to the limit from the right, x equal to a equal to some constant l, right? And it's, I can write it like this, equal to fa, right? So if it has the derivative, then it's continuous, okay, at the same point. So here is the proof. If you're interested, you can try it yourself. Okay, so in this, I think that you don't need to understand the whole proof. Okay, but it's quite interesting. If you want, you can read it yourself, and have any question you can ask me later. Okay, one of the most important thing about this, okay, is that the converse is not true. Okay, not true. When you have the continuous function, it doesn't mean that it's differentiable. Okay, you cannot conclude that. For example, this one, right? The derivative of fx equal to the absolute value of x at x equal to 0, right? We already know that this thing is continuous. Okay, right? This thing is continuous, but how about the derivative? Okay, so please wait a moment. Okay, so the derivative is f prime x equal to the limit of delta x approaching 0, f of x plus delta x minus fx over delta x, right? And this thing, the limit of will be absolute value of x plus delta x minus absolute value of x over delta x, right? But in this case, you cannot just do it directly like that. You need to, because it's the absolute value, right? You need to look from the left. So delta x approaching 0 from the left of the absolute value of x plus delta x minus absolute value of x, and the limit of delta x approaching 0 from the right of x plus delta x minus absolute value of x. Okay. Oh, and okay, so can I modify this one a little bit so it will be easier to understand? Okay, because in this they ask you to find at x equal to 0 already, right? You can replace x with 0. Okay, so this thing you can replace all this with 0. Okay, so it's easier for you to understand. Okay, because you will not get a condition that will confuse. So this thing will become the limit of delta x approaching 0 from the left of absolute value of delta x over delta x, right? And this will become the limit of x from the right of absolute value of x over, right? Like this. It's very similar, but when it's approaching 0 from the left, right? This one is 0. Approaching from the left, what happened? It is negative, right? So the absolute value of the negative number will become equal to delta x, will become minus delta x over delta x. And when it's coming from the right, when it's coming from the right, it's positive, right? So it's become the limit delta x of delta x over delta x. And this thing can cancel. And you get the limit delta x approaching 0 from the left of -1. And the limit of delta x approaching 0 from the right of 1, which equal to -1, and this one is equal to 1. Right? You can see that the limit from the left is not equal to the limit from the right. That means the limit does not exist. Okay, the limit does not exist, which means that this derivative is not exist. Okay, so you can see that the continuous function might not be the differentiable, or does not have to have the derivative. Okay. Okay, now let me see. Okay, so this is the last one. Okay, for the using the definition, right? So for this one, they ask you to compute the derivative, right? F prime of x. So f prime of x is equal to the limit of delta x to the 0, f x plus delta x minus f of x over delta x. And this thing is the square root of x plus delta x minus the square root of x over delta x. Okay, so this one, what I'm going to do, I'm going to use this b square equal to a plus b, a minus b. Okay, but this one I'm going to reverse. Okay, last time I do this, right? I have x square plus b square, x square minus b square, and then I change it to a plus b multiplied by a minus b. But this time I will see this to be a minus b. Okay, then I'm going to multiply by square root of x plus delta x plus square root of x. Okay, in both numerator and denominator. Okay, so this thing, the limit will become x plus delta x minus x. Okay, is it clear here? So this is a, okay, and this is b. Okay, so a minus b multiplied by a plus b, you can change it to a squared minus b squared. Okay, and x square root of x squared is just x. Okay, so we get this over delta x and square root of x plus delta x plus square root of x. Okay, and you can see that maybe delta x plus delta x minus x, and then delta x here, square root of x plus delta x plus square root of x. Okay, this cancel, right? X and minus x cancel each other. You will get the limit of delta x to 0 of delta x over delta x, and like this, and delta x is also cancel each other. Now you left with the limit of delta x of 1 over x plus delta x plus square root of x. Okay, and when you take the delta x approaching 0, you get 1 over square root of x plus square root of x, which is 1 over 2 square root of x. Okay, so this is how you derive the derivative by using the definition. Do you have any question here? Okay, if you don't have any question here, then we're going to the next part, which is the derivative formula, right? As you can see that finding the derivative by using the definition is very complicated, right? This one is a bit complicated, but 1 over x squared, right, that we already done in this one, is very confusing. Okay, so you can use another approach, which is using the formula, the derivative formula. Okay, and calculating the derivative is much easier and faster. Okay, I'm not sure that you will get the formula sheet for the derivative or not. Does Ajahn Part1 told you that is he going to provide you the formula sheet, or the exam will be open book? Can anyone tell me about the exam. Okay, so it's open book, so you can just find the formula, okay, in your sheet. Okay, there are many formula, right? This is just the first 6 formula that you need to know. And I think if you want to do your exam faster, this 6 formula, if you can remember it, then it's going to be much easier, much faster for you to do your exam. Okay, the first one is very easy, right? The derivative of the constant is always 0. Okay, the derivative of -1 is 0. The derivative of 5 is also 0. Okay, the constant, the derivative of the constant is always 0. Okay, and the derivative of x, okay, you can see here x, and then you differentiate by x like this, it's always equal to 1. Okay, okay, constant, the derivative of constant is 0. The derivative of itself, x itself, is 1. So it can be changing the variable, so it's become dt by dt is also 1, right? The second one is if you have the constant, okay, multiply by some function, you can just take the constant outside, like d of 5x over dx will equal to 5 dx by dx, like this. Okay, the next one is if you have addition or subtraction, then you can do the derivative separate, right? So d of x plus x squared dx equal to d of x by dx plus d of x squared by dx, like this. Okay, and I have to tell you that that d fx by dx is just the another notation of the derivative, the f prime of x. Okay, and for the fourth one, you can see that if we have the power, right, power of n, you can take n to the front and the power will -1, and then you do the derivative of the function. Okay, for multiplication and division will be more complicated. Okay, so if you multiply by v, then the derivative of uv equal to u dv plus v du. Okay, and for the division, okay, u over v, like this, it's become this whole thing. Okay, v du minus u dv over v squared. Okay, I'm not going to in detail about this one because you can open book, so you can look your formula. Okay, but I'm going to find a derivative for you. Like if you want to find the derivative of this by using the definition, it's going to be very hard work. Okay, but when you're doing it for by using the formula, then it's going to be much easier. So f prime of x will equal to, right, maybe I will just write step by step, dx, right, of 2x to the 9 minus 5 over x plus 7x. Okay, if you can do it by yourself, you can just do ahead. Okay, and if you have question, you can ask. Okay, but I will do step by step first, and after that I will do it faster. Okay, so it is plus and minus, right? Addition and subtraction. So you can separate dx to each of them. So it's become d of 2x over 9 dx minus d of 5 over x dx plus d of 7x dx minus d of 1 dx, like this. Okay, d of 1 dx is equal to 0, right, from 1. Okay, and this one I use formula 3, and now maybe I just modify this one a little bit so it's easier. So it's become 5x to the minus 1. Okay, 1 over x is equal to x to the minus 1. Okay, so now it's become of x to the 9 over the x minus 5 d of x minus 1 dx plus 7 dx by dx. Okay, okay, so in this part I'm using the formula number 2. Okay, and this thing equal to 1. Okay, by 1. Okay, now the x to the 9 power, right, is this one will become 9x to the 8 minus 5 x to the minus 1 power, so it's become minus 1 x to the minus 2. Okay, and then plus 7. Okay, and that's it. The by dx is already vanished, so you can answer it like this, or you can simplify it. It becomes 18x to the 8 plus 5x squared plus 7. Okay, so this is the answer. Okay, so does anybody already finish this? The part B. What is the derivative of gx? Okay, so try to answer it yourself first, and after that I'm going to answer. Okay, I am going to write the answer. For the derivative, and also in the future, right, you're going to study integral, you need to try to do it yourself, because if you not do it yourself, then when you see the exam, and then you cannot do the exam. Or you want this one? So today we study till 15:30, right? Okay, so I think you have done it or trying to answer this one, I will just write. Okay, and then you can check your steps. Okay, so it's become d by dx of the cube root of x to the fourth plus 1 over cube root of x to the fourth plus 2. So the cube root, okay, x, the cube root or the nth root like this, okay, is equal to x to 1 over n, okay, x to the power of 1 over n. So in this one, I will just rewrite it first. This one will become x to the 4 over 3 plus x to the 4 plus 2, 1 minus 3, like this. Okay. Now it's addition, so I can write it as x to the 4 over 3 dx plus of x to the 4 plus 2 over 1 minus 3 dx, like this. Okay. And d of x to the 4 over 3 will become 4 over 3 x to the 4 over 3 minus 1 plus minus 1 over 3 and x to the 4 plus 2 minus 1 over 3 minus 1, and then d of x to the 4 plus 2 over dx. Okay. This thing will become 4 over 3 x 1 over 3 minus 1 over 3 x to the 4th plus 2 minus 4 over 3. And then this thing you can separate to d to the x over 4 dx plus d of 2 dx. This thing equal to 0, right? So it's become x to the 1 over 3, 1 over 3 x to the 4, and x to the 4 will become 4x over 3. Okay, so this is the answer. Did you get the same answer as me? Okay, so did you finish this one? Okay, so I think you already finished. For the next one, now it's become the multiplication. Okay, so we want p prime x is equal to d of 2x over 7 minus 1 and 5x to the 9 minus 10 dx, right? This is the multiplication, so it's become 2x to the 7 minus x 1 d of 5x to the 9 dx plus x to the 9 minus 10 of okay, and this thing will become 2x to 7 minus x, and the derivative of 5x to the 9 minus 10 will become 45x to the 8, okay, plus 5x to the 9, and this thing will become 14x to the 6 plus x to the minus 2. Okay, okay. So there are several examples for you to try to understand it. Okay, there are many examples here. So for this, it is the divide, right? The division. So you can try to understand it yourself here. Or other questions? Okay, and this one, I think you please try to answer yourself, and on Thursday, right, I will going to answer it for you. Okay, so try to do it, okay, yourself. As I already said, this one is 8x to the 4 over 2 minus x 7, and it's 1 over 2, like this. Okay, for this one, previously you already they already asked you to find the slope, like slope of the they ask you to find the slope of the tangent line, right? You can find it by f prime of x, but in this one they ask you to find the equation of the tangent line. Okay, so when you going to find the equation of the tangent line, first you need to find the slope. Okay, when equation, first find the slope. Okay, and the slope of this tangent line is just the y prime or f prime of x. Okay, sorry, the same is d by dx of 1 over to the fourth part s. Okay, so this thing equal to dx and x to the fourth part x, and is minus 1 over 2. Okay, so this thing will become minus 1 over 2 of x to the fourth plus 8x, and minus 1 over 2 minus 1 d of x to the fourth plus 8x dx. And this thing will become 4x cubed plus 8. Okay, you already find the slope, right? But they ask you at x equal to 1, right? At point x equal to 1. So you find f prime of 1, which will become minus 1 over 2, 1 to the 4, 8, 1 minus this one, 2 plus 8, which is 9 minus 3 over 2 multiplied by 12. And this thing is equal to minus 1 over 2, 3 minus 2. Okay, become 6. Okay, this thing is just the calculation. You can if you cannot follow in here, you can try to do it yourself again. So it's become minus 2 over 9. Okay, so now you get the slope at x equal to 1. The second thing you want to find is the of y at x equal to 1. Okay, you find the value of y at x equal to 1. So you get What is y? Y fx equal to 1 over x to the 4th plus 8x. Okay, so f of 1 is equal to 1 over square root of 1 plus 8, which is 1 over square root of 9, which is 1/3. Okay, so you get the value of f at x equal to 1 and the value of the derivative of f when x equal to 1 already. Now you're going to find the equation of line, right? The slope of tangent line can be described by y minus y0 equal to m of x minus x0. Okay, m is f prime x. Okay, so this thing will become y minus 1/3 equal to minus 2 over 9 x minus 1, like this. And if you want to rearrange the equation, that's up to you. Okay, you want to change it to y equal to something, that's also possible. Okay, you can do it yourself. Okay, do you have any question here? So if you don't have, then I will continue with chain rule, and I think this is the last thing that I'm going to teach you for today. Do you have any question? Okay, so next I'm going to do the chain rule. Okay, so what is the mean of the chain rule? Right, you already use the chain rule in when you are doing this kind of derivative already, but I'm going to define the chain rule for you. Okay, so if you see that f, the big capital F, right, is equal to the composite function between small f and small g, right? It's defined by this thing: f of x is equal to f of gx, like this. Okay, when you do the derivative, right, then you will get this formula. Okay, or we can write it like this also. Okay, and when you can composite more than just 2 function, you can 3 function, 4 function, like that, right? You can see that y is the function of u, right? And u is a function of x is a function of t. When you want to find the derivative of y with respect to t, then you can use the chain rule like this. Okay, you can see here. You can see when you find the derivative, right, of y equal to this thing, right? You just consider like y equal to square root of u, and then u is v plus v squared minus 1, and v equal to x to the 2/3, like this, and then you do the chain rule. Okay, I'm going to let you see that you already see the chain rule in the first formula, right? This first set of the formula, which is here, this one. Okay, this one is the chain rule already. Okay, because you just you want to find the u to the n by the x, then you differentiate the du by using the exponential first, the power first, and then you differentiate the du again. Okay, so you already use the chain rule. Okay, but now I'm going to let you see the chain rule in more detail, right? You can read this thing by yourself. Okay, so maybe I will just start with this one. Okay, and I think this one is maybe the last one question. Okay, and after that I will just let you ask me if you have any question. Okay, so in this you will see that y is the function of u, right? U is the function of x, and x is the function of t, right? So they want to find dy by dt at t equal to 11. Okay, we will just ignore t equal to 11 for the moment. Okay, dy by dt is equal to dy by du multiplied by du by dx multiplied by dx by dt. Okay, now we differentiate, finding the derivative of each of them. So it's dy is u squared over u cubed minus 16 by du. Okay, is one. Another one is d by dx of 3x squared minus 8. And the last one is d by dt of the fourth root of t plus 5. Okay, okay, so I'm going to do each one. Okay, let me see. Okay. maybe I will just do it separately first and then combine it again. Okay, because the first one you're going to do there's very much work. U square over u this thing, right? And you can do this in two ways. Okay, first you're using the quotient rule, okay, or the divide the x of u over v. Okay, you can use this one, or you can see it is u over v, right? So you can see it as u and then v minus 1 like this, and you do the multiplication rule. You can do both of them. Okay, but in this case I will using this one. Okay, so this thing will equal to the of u square and then u cube 16 minus 1 like this, and then do the multiplication rule. So d of u cube minus 16 du plus u cube du square du, and this thing will become minus 1 u cube minus 1 minus 1 and d u cube 16 and this thing is become tu 2u like this. U square minus 1 u cube minus 16 raised to minus 2, and this thing will become 3u square plus 16 minus 1 2u. Okay, so this one is just this part. Okay, the next part is the x by the x of 3x squared minus 8. Okay, and this one is easy. It's become 6x. Okay, just 6x. Okay, now the last one, d by dt of fourth root of t plus 5. This thing will become of t plus 5 1/4 like this. T plus 5. Okay. Okay, so dy by dt equal to this thing. multiplied by 6x multiplied by 1 over 4 t plus 5 minus 3 over 4. Okay, and if you want to do it as the above example, so you need to change it to dt, right? This one is you change every variable to x, right? From you start with u, v, and x. You change everything to x, right? In this, you also can change everything to x. In this case, into t, right? Because you already know that x is equal to the fourth root of t plus 5, and u is equal to 3x squared minus 8. So this thing you can change u to 3x squared minus 8. So it's become 3x squared minus 8 square minus 1, 3x squared minus 8 cube minus 16, and then 3 of 3x squared minus 8 square, okay, plus 3x squared minus 8 cube minus 16 minus 1, and then 2 of 3x squared minus 8. Okay, so this is one bracket from this one. Okay, and multiply this by 6x and 1 over 4 t plus 5 minus 3 over 4. Okay, next you change x to t. Okay, so it will become, you change every x to fourth root of t plus 5, right? So it's become 3 of t plus 5 square minus 8 square minus 1, and so on like this. Okay, and then you get the derivative of y with respect to t. Okay, and when you get everything here already, then you just it 1 at t equal to 11, right? So then you can plug in 11 into the variable t, okay, and then you will get the answer. This is one way. Another way is, if you want to find this thing, t equal to 11, right? Then you know that x equal to square root of t, no, not square root, the fourth root, so it's t plus 5, right? So when t is equal to 11, x equal to of 11 plus 5, which is the fourth root of 16. Hello, can you hear me? Excuse me.